Hello, in this video we are going to continue our work with index laws. We are going to review the ones we have seen already, we are going to introduce new ones, and we are going to practice a bit. We have two positive numbers, a and b, and we are assuming that the indices m and n are integers, so they're whole numbers. The first law that we saw is that if we have a to the power of m and we multiply it by a to the power of n, then that's the same as writing a to the power of m plus n. Let's call this law 1 to refer to it later. For instance, let's say we have 7 to the power of 2 and we wish to multiply it by 7 to the power of 3, so we have the same base 7. Then this is going to be the same as considering 7 to the power of 2 plus 3, so 7 to the power of 5. So that would be the simplified way of writing this. I'm not interested at this point at finding what number actually is 7 to the power of 5. I just want to write it in a nicer way. The second law, number 2 over here, tells us what to do when we are dividing two exponents with the same base, a to the m divided by a to the n. And we need to find a to the power of m minus n. For instance, let's say we have 10 to the power of 6 and we are dividing it by 10 to the power of 4. We want to simplify this expression. We can write that this is 10 to the power of 6 minus 4. So we can write 10 to the power of 2. The last of the laws that we are reviewing refers to the case where we have a exponent of exponent. So we have a to the power of m and then all of that to the power of n. And what we need to do is to consider the base a to the power of m multiplied by n. Let's say we have 2 to the power of 5 and then we are considering all of that to the power of 3. So we need to do 2 to the power of 5 times 3. So we need to do 2 to the power of 50. So these are the first three laws that we have seen. For number 4, we consider the following case. We are multiplying two numbers a and b, and then we are considering the power n of that product. So what I'm saying over here is that I'm multiplying ab times ab and times. Since we are multiplying the numbers, the order I do it doesn't matter, so we are allowed to write first all the a's that we are multiplying, so they are in total n of them, and then all the copies of b that we have, and we are multiplying, so they are also n times n copies of them. So in other words, we can write this as a to the power of n times 2e to the power of n. So let me just write over here, the property says a times b to the power of n is equal to a to the power of n times b to the power of n. We have also a similar property if we are dividing a by b, so we have a over b to the power of n. We could write that we are multiplying the fraction a over b times itself n times. So we have, when we multiply, a to the power of n in the numerator and b to the power of n in the denominator. So this property reads a over b to the power of n is equal to a to the n over b to the n. And that's how we can get rid of the bracket. I need to make a bit of space over here so we can see all the laws that we are considering at the same time. So here we have what I call number 4, and here we have what I call number 5, and then I'm going to erase the work we did to get to them. And now I think we are ready for two more properties. For number 6, I'm going to write that a to the power of 0 is equal to 1. And this is the case when a itself is not 0. You can check this property in your calculator, of course, And later on, we're going to have a good explanation of why defining a to the power of 0 as being 1 for a different from 0 makes sense. For the last property, I want to mention something that we check on class with the calculator a few times. What happens when we do a to the power of negative 1? We saw that that gives us 1 over a. Well, we need here to make sure that a is not 0 as well. If we try to do a to the power of negative n, let's say again that a is not 0, and let's say that n is a positive integer, we can notice that this is the same as doing a to the power, and when we say negative n, we can write this as multiplying negative 1 times n. That's the same. And now I want to use the property number 3. Property number 3, if I'm reading it from right to left, it says that when you have a to the power of the product of two numbers, you can do a to the power of one of them and then the power of all of that. So I'm going to do that. I'm going to, in this case, I'm going to write that this is the same as doing a to the power of n and then all of that to the power of negative 1. And now, because we know how to do the negative power of a number, we say that we need to do the reciprocal of the number. So I'm going to have 1 over a to the n. So my property says that a to the power of negative n is the same as 1 over a to the n. And that's our property 7. And let me move the properties to the top so we can have a bit of space to practice. We want to write in simplest form with a prime number base the following expressions. Let's say we have 25 to the power of 3. Okay, so if I'm saying a prime number base, that means that the number 25, I want to write it on its prime factorization, which in this case is just 5 squared, which is very simple. So I'm going to write that instead of writing 25, so I'm going to have 5 squared and then all of that to the power of 3. And now we can use the third of our properties to say that this is the same as 5 to the power of 2 times 3. So this is 5 to the power of 6. This was our example A. Now for B, we want to have 9 multiplied by, and then we just have 3 to the power of t, and we don't know what is t, so our answer is going to be in terms of t. We are going to write 9 as 3 squared, because that's a prime factorization, and then we are multiplying that by 3 to the power of t, whatever that is. And we can use the first one of the properties. It's a good idea to write which property we are using on each case. To write that this is 3 to the power of 2 plus t, whatever that number t is. For the last example, let's say that we have 7 to the power of x divided by 49 to the power of y. Again, because we want a prime number base, I'm going to write the denominator as 7 squared to the power of y. So in the denominator, we have 7 to the power of 2 times y, so 2y. And that was using our third property. But now if we use the second one, we have that this is 7 to the power of x minus 2y. For our last example, we are going to apply the index laws to simplify some expressions. The first one of them reads 3 times a times b squared times 2 times a cubed. So in this case, we have numbers. We have the variable a and the variable b, and we're going to try to write each of those together. So for instance, I'm going to write that we have 3 times 2. Because we have the number 3 and we have the number 2, we are multiplying. We can change the order of the factors in the multiplication as we wish. Then we have one copy of a times a, and then we have a cube as well. And then to finish, we have one copy of b squared. I'm just going to go over the factors I have in the original expression to make sure that I didn't forget anything. The number 3 is here, then we have the number 2 is here. Then I say we have a copy of a alone is here, and then a cube is over here, and then b squared is here. So I just quickly made sure that I didn't forget anything, and I didn't write anything extra either. That was just a check for myself. So now let's see what we have here. We have 3 times 2, so we have 6. And then we have a times a cubed. Notice that a is the same as saying a to the power of 1. So we have a to the power of 1 being multiplied by a to the power of 3. If we apply the first one of the properties, this is a to the power of 1 plus 3. So I'm going to write that after the 6, I'm multiplying by a to the power of 4. And then at the end, we have b squared. So I can write this without writing the product sign, 6a to the 4 b squared. I'll write example 2 here on the side. We have 4a cubed d squared, all of that square, and divided by a squared d. Okay, well, the first thing I'm going to do to simplify this a little bit is to get rid of the bracket square on the numerator. And I'm going to do that applying the property number 4 that says that we can do that if we square each of the factors we have inside. So we have 4 squared times a cubed squared times d squared squared. And I'll write the denominator a squared d as it is. Again, the property I use over here is the one that we call, sorry, not this one, is 4. So I got rid of the bracket by putting that exponent at each one of the factors, which in this case were 3. So what we have here, we have 4 squared. I'll leave it like that for now. We have a to the power of 3 to the power of 2, so I'll use the property number 3 that says to do the power of a power I multiply the exponent, so a to the power of 3 times 2 is a to the power of 6. And then we have d to the power of 2 to the power of 2, so d to the power of 4, and then divided a squared d. Now for numbers, the only thing we have is 4 squared, so I'll just write 16. We have a to the power of 6 being divided by a squared, and d to the power of 4 being divided by d. And I can write it in this way because that's how we multiply fractions. We multiply numerators and denominators. So we have over here 16, and then we have a to the power of 6 divided by a to the power of 2. So I'm going to use over here the property number 2. That is the one we have here. We haven't used it that much yet today. So I'm going to write that this is a to the power of 6 minus 2, so a to the power of 4. And then we have d to the power of 4 divided d. Remember that we can see that as d to the power of 1. So we have d to the power of 4 minus 1, so d to the power of 3 is our answer.